The last transformation we're going to talk about is reflections or flips. So before we start looking at flipping actual graphs, let's look at points. Let's consider something a little simpler. So the point 2,4 is here. Let's say that I want to do a vertical flip, okay? And you guys are familiar with vertical flips with parabolas last year. Yes, you are, okay? Then you're going to have to review. So that means a negative goes in front of the function, okay? And it's a vertical flip, but it goes over the x-axis. So if we go over the x-axis, and if it's a vertical flip, the negative's in front, it goes from a vertical height of 4 down 4 here. So the x stays the same, it's the y that changed. So the new point after you vertically flip it over the x-axis is 2, -4. Going back to the original point, 2, 4, if you flip it horizontally, it's going to get flipped over the y-axis. Okay. Remember, horizontal, that's what happens inside the function, which is why we put a negative inside in front of the x. And when you flip it, it's a horizontal distance of 2 from the y, so its flip, or its reflection, will be 2 on the left, horizontal distance. So the x changes to -2, the y stays the same. So we can add that to our, oh, tell me I didn't. Oh, good, I didn't. I thought I closed that equation. So this becomes -2,4. So those are the two. If it's vertical, the negative goes in front with the A. If it's vertical, the negative goes inside in front of the X with the B, if there is a B. So let's look at vertical reflections or flips. Okay. And again, there's 2 ways you can do this. You can kind of do it in your head on the graph, or you can use mapping notation. So like I said, every vertical flip or reflection goes over the x-axis, and every y value changes signs because vertical affects the y. So xy becomes x -y. So here we're given a function in the shape of a W. We are asked to vertically flip it over the x-axis. You could use this if you want to, or you could do it right on the graph, okay? Perhaps this one, the graph might be easier because you just find points on the original graph and flip them over the x-axis. So I'm going to use this point at the end of the arrowhead and this here. So I'm going to flip, it's 4 up, I'm flipping 4 down. This is on the x-axis, so when I flip it, it stays where it is. This goes from 2 up to 2 down. This stays where it is. And this goes from 4 up to 4 down. So it looks like this, and we've got arrowheads on the end because it continues forever. So that's using the graph. You could have used the points. So the points I had were -5, 4, -1, 0, 0, 2, 1, 0, and 5, 4. And for mapping notation, the new formula for every point, if all I'm doing is a vertical flip, I just change the y to negative. And then I just change all these. And if you find if you change all these, you're going to get the points that we did mentally, that we did right on the graph. I get -5, -4, which matches up with that one. You're going to get 0, -1. Or sorry, you're going to get -1, 0. It stays where it is. -1, 0. You're going to get 0, -2. 1, 0 stays where it is, and 5, -4. So again, you've got a couple of choices. Any invariant points, and if so, what are they? Remember what invariant points are? They don't change after we do a transformation. -1, 0, and 1, 0. They didn't move. Another example. Here we're told to graph a specific function, and you should know how to graph this. You know how to graph x squared. It starts at the vertex, then you go 1, 1, 2, 4. But this one is starting where? It's a parabola, but where does it start? 4 down from where this one starts. So x squared minus 4 is going to start down here. And then I go 1 across, 1 up, 2 across, 4 up. And there's my boy, it's hot in here. How would you graph g of x? Wait a minute. I don't know how to count. Actually goes right on the x. Makes it easier to see the invariant points. So what do we do when we vertically flip it? Just take these points that we put on x squared minus 4, flip them up. So what we're doing is we're putting a negative in front of the whole function, which is the same as -x squared plus 4, which makes sense because if we flip it from this graph, this becomes up here, this goes here, this goes here, these two stay where they are. That actually makes sense that it's -x squared plus 4, because the vertex went 4 up and then it flipped, right? So this is y equals -x squared plus 4. So whenever you apply a vertical stretch to an equation, you put a negative on the whole function. Invariant points? Yeah, -2, 0, and 2, 0. Okay, so that's vertical. Let's look at horizontal. Or reflections. When we're flipping over the y-axis, that means it's a horizontal flip, which means every x value is affected. So every x value changes sign. So in mapping notation, it goes from positive x to negative x. So again, and notice I didn't give you a mapping notation because this is pretty straightforward. All I have to do here is flip all the x coordinates, or sorry, change the x coordinates to negative or flip it over the y-axis. So we can do this. But, I'm going to put points there so I know where to flip them. So this is 5 away horizontally, it goes to here. This is 1 away horizontally, it goes to 1 away on the other side. This is right on the y-axis, it just flips over and stays where it is. This is 1 to the right, it flips 1 to the left. This is 5 to the right, it flips 5 to the left. And I put my arrowheads on the end. So that's really it. Like I said, if it's like 1 transformation, maybe 2, you can probably get away with doing it right on the graph. Once you start getting into more complex ones, you want to rely on mapping notation and finding formulas. And we're going to practice it with that. The next thing we're going to do after this is put them all together, and we're going to spend some time on that. What are the invariant points or points on this? Careful. 0, 2. Here we're back to a parabola, and then we're asked to flip it horizontally. Well, we should remember how to graph this. This is taking a parabola from a vertex of 0, 0 and going where with it? 1 to the left and 9 down. So we normally start here, we go 1 to the left, 2, 3, 4, 5, 6, 7, 8, down here. It's positive, no number stretching it. So it's just what we call, I kept calling last year, a regular parabola. It's going to look like that. So this is h of x equals x plus 1 all squared minus 9. When we do a horizontal flip, in the equation, we just throw a negative in front of the x inside. So the new equation is I take this one and I just drop in a negative right there. So everything else stays the same, except it's negative x plus 1 squared minus 9. What would the graph look like? Done that in red. I'm going to do the graph it in red. Well, just look at the graph. We've got 5 reference points on the original. Flip them horizontally. So this one goes over here. This one goes over here. This one goes over here. This one doesn't go anywhere. This one goes back over here. So this is the flip one horizontally. So this is h of x equals negative x plus 1 all squared minus 9. Any invariant points? 0, negative. So I'm going to talk about this again next class, but I'm just going to go back to this. And add to it. What we did today. If there's a negative here, remember it's outside, so it's vertical. So if negative, it's a vertical flip. If it's inside the function, it's horizontal, affecting the axis. So if negative, horizontal flip. So there's the 6 transformations, and feel free to take a photo of that, because that's a good thing to have as a study reference, to remember all the transformations. Okay? Because we've done 3 types of transformations. For each one, there's 2, vertical and horizontal, which means there's 6 total transformations. So our next step is going to be to put all of them together. So we may see 3 in one equation. We may see 2 in one equation. But we won't see just 1. What we did in the lessons is we kept all the transformations pretty simple. Okay, just to show you what's happening in terms of shifts, stretches, and flips. But now we're going to get more complex ones, and we're going to do 2 basic things with them. You're going to be given a graph, you're going to be given an equation, and you're going to be asked to sketch the new graph. Or you're going to be given an original graph, a transform graph, and you're going to have to figure out what the equation is. Okay, so that's sort of what's coming up next. And I think we're going to spend the rest of the week, Wednesday and Friday, on that. Maybe even a little bit next week too. Because that's this next lesson is sort of, it's kind of the meat of the unit. So for Wednesday, I'd like you to do exercise 1.4, please. And I'll just, let me just save this.